On page 70 of the Schillinger system of musical composition, Schillinger says, while rhythm evolves within musical measures themselves also evolve their own rhythm. And this is the essence of what he means by fractional and factorial. Factorial is the rhythm of the bars. Fractional means the rhythm in the bar. And the two are intimately related by a technique known as distributive powers. Schillinger's approach starts with the observation that when we look at Western music, and the music of many other cultures, we find that they are rooted in the number 2 and its multiples. Perhaps in some senses this isn't very surprising. After all, we as human beings exhibit bisymmetry. We have 2 eyes, 2 hands, 2 feet, and so on. Perhaps in music this explains why there are so many occurrences of 2 and its multiples. The classical theme and the contemporary dance track are equally likely to consist of 16 beats arranged as 4 bars of 4/4. Of course, non-duple meters and rhythms appear frequently in all styles of music, but their treatment is still heavily influenced by the number 2 and its family of multiples. So for instance, meters of 3 or 6 are usually grouped in phrases of 2 or 4 bars. Schillinger wasn't the first to make a connection between 2 and its multiples, forming a power series, a series of squares, 2, 4, 8, 16, 32, 64, and so on. But his observations led him to speculate about the logical consequences of using power series in music. And so we come to what could be called the squaring axiom, and that is the number of beats in the bar equals the number of bars in the bar group. If a bar of 4 beats usually participates as one of a 4-bar group, making a 16-beat cycle in all, then other meters should follow the same principle. A bar of 5 beats should be part of a 5-bar bar group, making 25 beats in all, and so fulfilling the tendency of the square. The process by which we turn a bar of rhythm into many bars is achieved through the use of a simple quadratic equation. The starting rhythm, that's the 1 bar of music, is called the seed. The equation can be described in words. Let's suppose that a seed, a whole bar of music, is represented by 2 durations A and B. First, A is multiplied by itself, then by B, then B is multiplied by A, and finally by itself. When we do this to a seed of the correct length, we end up with a new rhythm that fills the entire bar group. You can see that the number of elements in the seed, in this case 2, is squared, producing a number pattern with 4 durations. Perhaps most significant is that the features of the original seed, whether they be short-long or long-short, are reflected in the new rhythm. Its proportions are maintained. Now, instead of A and B, let's use the number pattern 3, 1,